Alright, hey guys, so today we're going to be talking about the properties of logs, which are going to help us to expand and condense our logs. So the first property that we're going to talk about is the product property. So whenever we're taking two logs that are multiplied, so we've got log of m times n, that's going to be able to separate into log base b of m plus log base b of n. So instead of multiplying, we're going to separate them and add. So on all of our examples, we're either condensing or expanding, and in this first section it says condense, so on 1 through 3 we're going to be condensing them. So we see log base 2 of 7 plus log base 2 of 4. They do have to have the same base in order for this to work. So we see that in the property they both have to be log base b. So on our examples, we got to make sure that the bases are the same, and then we can condense them. So we've got log base 2 on both of them of 7 times 4, which we could condense even further and say that this would be the same thing as log base 2 of 28. On number 2, so last time we talked about logs, we know that whenever we have no base written, that it's a base of 10. So this is log base 10 on both, and so we have 25 times 4, which again we can condense even further and say that this is log 100. And you can either write these without the parentheses or with the parentheses. I prefer to write it with the parentheses just because I feel like it's easier to see with the parentheses there where the base is versus what is going into the log. And so you see that when it's written like this, we don't know what the base is really, especially with when we're handwriting them, the 2 and the 7 might look the same size. So that's just why you'll see me write it with the parentheses there. Now, number 3, they both have log base 4. We've got 2x times 4x squared. So we've got log base 4 of 2 times 4, which is 8, x times x squared, which is x cubed. And we're going to talk about how to condense that even further in a little bit on here. But we'll stop there for now since we're just talking about that product property. So now in the next section, 4 through 6, we're expanding. So we're going to get one single log and we want to expand it as much as we can using the product property. So in number 4, we have a log of base 10 of 6. So what two numbers could we use that multiplied together would give me 6? Well, I could say this is log base 3 plus log base 2. Not base, sorry. Log of 3 plus log of 2, because then I would, in order to condense that, multiply them together. And there's no specific answer on these expansions because there are multiple ways to multiply to a number. And so with 6, it's kind of obvious that we can use 3 and 2, but on other numbers, it might not be so obvious. So like on number 5, log base 7 of 45, we could use 9 and 5. We could use 15 and 3. And so we see that there are multiple ways for these logs to be expanded. And we would have the same answer. So number 5, either one of those would suffice as an answer since we were able to expand it into 2 separate parts using the original log. And then on number 6, we can separate that 5x, and so we've got log base 2 of 5 plus log base 2 of x. And so we see that now I'm not writing it with parentheses. So again, it's completely up to you of which one looks better to you, which one's going to be more clear for you. A lot of times when there is that multiplication in there, you will see it with the parentheses. Now, whenever we are using a quotient, whenever we have division in there, we've got m over n instead. But we've got to make sure they have the same base again of b. We would have log base b of m minus log base b of n. And so it works the same way. We're going to condense them on the top three and then expand them on the bottom three. So whenever there is subtraction between two logs with the same base, we will take the first over the second. So the one that has the minus in front of it will be our denominator, and that does matter. And we could condense even further and say this is log base 3 of 3. Number 8, they both have a base of 2. 15 over 15, which would be log base 2 of 1. And one of the important properties when we have log base anything of 1, log base b of 1 equals 0. So whenever we have the same number and the same base, we're subtracting from itself. So we end up with 0 as our answer on number 8 because we are subtracting from ourselves all that we have. We end up with nothing. So this is just a special one to know. Then on number 9, we're going to make sure they have the same base. They have both a base of 4. We're going to take x to the 9th power over x squared. And then we know that we subtract those powers, so we get log base of 4x to the 7th. And then in that last section, that last property we're going to go over, we're going to talk about what to do when we have those powers. Now on 10 through 12, we are expanding using the quotient property. So we're going to change 4 into something that could be over another number. So we could say that's 4 over 1. We could say that that's 8 over 2. So let's do 8 and 2. So we would have log base 8 of 8 minus log base 8 of 2. And then we're expanded there. Another property to know is that log base b of b is equal to 1. So here we have 1 minus log base 8 of 2. So just another property. Whenever you've got the same base and the part going into the log, it's going to equal 1. So now we're expanding this. We've got log base 5 of 1 minus log base 5 of 3. And remember, when we've got log base anything of 1, it's going to be 0. So we've got 0 minus log base 5 of 3. Number 12. Remember, when we don't see the log base, it is a base of 10. So we've got log base 10 of m minus log base 10 of 7. And now the last property that we're going over is the power property. And so whenever our last term here, this m to the nth power, if we have a power on it, when we condense it, we'll take n in the front, log base b of m. So it becomes the coefficient on the entire log. So on numbers 13 through 15, we're condensing them, and they have that coefficient there. So we'll take log base 4 of 2 to the 5th power, which we could change to log base 4 of 32 14 log base 2 of x to the 7th power. So remember that coefficient on the front becomes the power on it. Now on 15 we have a 1/3 power. So our base is 10. We've got log 8 with a power of 1/3, which we can change to log and the cube root of 8. So remember, whenever we're taking the power to a fraction, then that's going to change into a radical. Now in the next part we are expanding. So the 7 will come down, log base 2 of 8. Then on number 17, log base 10 of 4 to the power of x minus 1 to the power of 3. Remember, whenever we take a power to a power, we multiply. So we've got 3x minus 3 as the new power on that log. And now on number 18, remember that the square root of anything is that thing to the 1/2 power. So we have log base 7 w to the 1/2 power, which would equal 1/2 log base 7 of w. So now I am going to go over some of the problems that were on your homework, that are on the homework for tonight, but the only ones that you will have to do, since there are 2 separate notes videos for today, are 1, 3, 9, 11, 13, and 15. So the ones that are highlighted in yellow are for you to turn in, and the ones that are highlighted in pink I'm going to quickly go over. So if you don't want to see this part of the video, then you can go ahead and click out and then start on the next video. But if you do want to see some more problems get worked through, then you can keep watching and then just make sure that you do the yellow ones for your homework. So on the top here, we're just going to write in all of our rules so we have them in one place. Product rule, we're going to add them together. Log base b of m plus log base b of n. Quotient rule, we'll subtract them. Log base b m minus log base b n. And power rule, we'll take that n and make it the coefficient in the front there. So n log base b of m. So on this part right here, it says condense as our instructions. So we're condensing into a single logarithm. So since we have subtraction, we're going to take those two and divide them. We've got 80 divided by 5, which is 16. So we've got log base 2 of 16. Number 4, we've got quite a bit going on here. So first thing we're going to do is make those coefficients powers. And I see they have the same base of 4, so I can keep going. So I have log base 4, and since it's subtraction, now I will be dividing. So I've got 8 to the 3rd power. I'm going to go ahead and write those as the expanded numbers. So I've got 512 over 2 to the 5th, which is 32. And 512 divided by 32 is 16, so we have log base 4 of 16. And so we got that from that very long log that we started with. And then on number 5, again, we've got a very long log here that we need to work with, but they have coefficients, so I'm going to move those to the powers first. So log base 5 x to the 7th plus log base 5 y to the 4th cubed log base 5 x to the 7th plus log base 5 y to the 12th. We've got a power to a power, so we'll multiply them. And now since it says plus, I'm going to multiply. So log base 5 x to the 7th times y to the 12th. And since x and y are two different variables, we'll just leave them that way with their multiplication in between. Number 6, log base 3 a to the 7th plus, and then we're going to do this part first since it's in parentheses. So they have the same base. This needs to become a power. And so we'll keep it in parentheses in case there are more steps. Log base 3 a to the 4th minus log base 3 b squared. And since there's a minus there, I'm going to make it into division. Log base 3 a to the 4th over b squared. And now I've got a log plus a log. They both have base 3, so I'm going to multiply a to the 7th and a to the 4th over b squared, which would be the same thing as taking a to the 7th times a to the 4th on the top, which we would add their exponents, a to the 11th over b squared will stay the same. And then once I'm there, since a and b are different, we can't condense any further. Number 7, we're going to subtract then add log base 4 of x to the 7th over x squared plus log base 4 of x cubed to the power 4. Log base 4, we're going to subtract those, so 7 minus 2 is x to the 5th plus log base 4 multiply, since it's a power to a power, x to the 12th. Condense by multiplication, x to the 5th times x to the 12th. They're both x, so I can go one step further. Log base 4 of x to the power 5 plus 12, which is 17. Now on this next one, we need to condense it down to one log. We have a fraction in the front, and then we've got a log in the end there as well. So we're going to take this 1/2 and make it a power. And we've got subtraction, so 45 over 5, and then the power of 1/2. Plus log base 6 of 12. So 45 over 5 is 9. The 1/2 power is the square root. Square root of 9 is 3. So this is log base 6 of 3 plus log base 6 of 12. And then we will condense one step further by multiplying. 3 times 12 which is 36. So log base 6 of 36. Now on the next page, the first part we're doing is to condense, then use the change of base formula to evaluate. So we're going to condense first. So we've got log base 3 of 8 squared minus log base 3 of 2 to the 4th, which would equal log base 3 of 64 over 16. So I just took 8 squared and put it over 2 to the 4th. Which is 4. So we've got log base 3 of 4. So we're going to use the change of base formula to evaluate that logarithm. So we're going to use log of base 10. So log of 4 over log of 3. And then put that in your calculator. And we get 1.262. So first we condensed to get it to log base 3 of 4, and then in order to evaluate we needed to use the change of base formula, so we used base of 10, and then we got our answer as 1.262. We'll do the same thing on number 12. We're going to condense first. So log base 2 of 27 plus log base 2 of 4 minus log base 2 of 3 squared. Log base 2 of 27 times 4. Looks like a point where I put it, sorry. Minus log base 2 of 9. 27 times 4, 108. Log base 2 of 108 minus log base 2 of 9. Remember, when we subtract, we're going to divide them. So we've got 108 over 9, which is 12. So we have log base 2 of 12. We're going to use the change of base. So this is log 12 over log 2. Log 12 over log 2 is 3.585. And then on this last section, we are now expanding. So we're given this single log with a base of 10, because it doesn't say. And then we have the subtraction. So we're going to take log base x9 minus log y to the 4th. And we could expand that further if we wanted, we need to. Sorry. I was going to say based on the powers and say this is x cubed times x cubed, but what we're going to do instead is take that 9 and make it the coefficient. So 9 log of x minus 4 log of y, and then we're done. So I do find it a little harder to expand just because we kind of don't know when we're done with the problem. as opposed to the opposite when we're condensing. We know once we get to one single log, we're pretty much done. So just be aware that, like, check, can I expand this any further? And a lot of times you can, so it kind of gets repetitive. So on number 16, again, we have a log of base 10. We've got a power on it, so we can say this is 2 log p to the 4th minus 2 log q to the 7th. So the reason I give them both that 2 in the front is because that power belongs to everything inside of there. So both the p to the 4th and the q to the 7th logs have that power of 2, which would mean they both have the coefficient of 2. So now we're going to take those other powers and move them down. So we would have 8 log of p minus 14 log of q. And remember, if you need to use those parentheses so you can see where the p and the q are compared to where the log is, then you can go ahead and do that. I've seen some people write log in cursive. So let's try that on 17 and see if you like that better. On 17, we've got a square root, which we know square root means, so square root of x is x to the 1/2 power. So we really have log of base 5, a to the 7th, b to the 1/2 power. So I'm going to take 1/2, move it to the front, log 5, a to the 7th, b. And I know a to the 7th and b are multiplying, so I can separate those. I've got 1/2 log base 5, a to the 7th, plus 1/2, remember the b is also underneath that radical, log base 5 of b. And we're not done yet just because that a still has a 7th power on it. So we're going to move it to the front. We've got 7/2 log base 5 a plus 1/2 log base 5 of b. So if using cursive to write log is easier for you to be able to tell the difference between my logs and my variables, then you can do that. I've seen people use capital letters all the way across with log, which isn't my favorite way to see it, but it is kind of helpful if, again, you're struggling to find your variables versus the log function itself. So now on number 18, the cube root of x without a power on it is x to the 1/3 power. So we have log base 4 c squared t to the 15th to the 1/3 power. We're going to move that 1/3 to the front, log base 4 c squared d to the 15th. We can separate them. 1/3 log base 4 c squared. They're multiplying right here, so we're going to add their logs together. D was also underneath the radical, so it needs that 1/3 in front of its log as well. Oh, forgot my base. And since they have those powers on them, the power is going to come down to the front, multiply by the 1/3, so I get 2/3 log base 4 of c plus 15 divided by 3 is 5 log base 4 of d. So if it's easier when you see log in all caps, since we use lowercase letters for our variables, then you can use all capital letters. You can use cursive for log, or on like number 16 and 14, you can just use all lowercase and just make sure that you are aware what is your log versus what is your p and your q, and etc. So that's it for today, which I know when just looking at it, it seems very overwhelming, but remember you're only doing the ones highlighted in yellow, which means you're only doing 6 of the problems, and then I did the rest of them. So make sure that you turn this in on Canvas, and then I will see you guys in the next video, which is also for today, going over natural logs.